starting streaming, so it is being recorded now. All right. So the first thing this is the first topic, is under data management. So there's one more thing that I didn't include in the outline, and that's IMS. So we'll go ahead and get to IMS at some point. Okay, I do have the research slide on the tabs somewhere. So the first portion is comparing a database, like a relational database in this case, with dataset, because dataset is the original idea of how we organize data. It's basically just a stack, a deck of punch cards. That is the original idea of a dataset. Is just we have records, and record is just one line. By our terminology, it is one line of text in a text file. But in the original technology, one line of text or one record corresponds to one punch card. So when you have a sequence of punch cards, then you have a data set. So that's the sequential data set, the most simple form of a data set. And these are just overall high-level concepts. A database, especially a relational database, now typically in industry, when people just use the term database, they are referring to relational database. IBM has more than just relational database, so we'll talk about IMS in just a little bit. So a relational database is very different compared to a dataset. A relational database, it doesn't matter how simple of a relational database we are talking about, they are still fairly complicated. So we are talking about multiple files, a whole bunch of files, a whole bunch of indexes, and you have a resident portion. So the database cannot exist just quote unquote as a file, just as something that is on a hard drive or something that is on the tape, which dataset can do. Okay, so when we refer to a dataset, we can just be looking at a tape, okay, at a reel of tape, and we can point to that thing physically and say, yep, that's our dataset right there. And we just have to read the records one by one sequentially. So that's the simplest way to read in the data and process the data, with dataset. At the same time, a database is not simple. It's never simple with a relational database. So a relational database requires a program to be running. So in IBM's term, it would be the subsystem. So DB2 is considered a subsystem. So is Oracle. It is also considered a subsystem. So a database, you can say, oh, but those files, those those particular data sets, is where the data is stored when the database is quote unquote offline. But if you want to utilize the data in the database, the subsystem has to be up and running. So that's one of the main differences between a database versus the concept of data sets. Now, when people need to choose or compare the two ways of organizing data, one consideration that is kind of specific to IBM mainframes and their clients. Let me zoom this in a little bit so that you guys can see it a little bit better. There we go. Okay, that should be okay. It's backward compatibility. One of the few reasons why big corporations like American Express, Wells Fargo Bank, why they, also the state agencies, why they want to continue to use IBM mainframe computers is because they want that backward compatibility. As long as we are still using IBM mainframe systems, old data sets that were set up and stored and backed up and archived decades ago, and we are not even talking about just 30 years ago, we're talking about 60 years ago, back in the 60s. Even those can still be processed, on a modern mainframe. All you need to do is to find the tape drive that can read those reels of tape, assuming that those tapes are still good to be read. But it's relatively easy to convert, a reel of tape into a form where you can put it onto a DASD, because it's just sequential. It's really just a sequential bunch of bytes. Even when we talk about VSAM, some of the more complicated data sets, we're still talking about a very good backward compatibility with older COBOL programs. Um, and this brings us to the second point, compatibility of how data has been organized and stored in past decades. So that is, I suppose, that's a good thing. I think Lupe, you work for the franchise tax board, right?
Yeah.
So as far as has there ever been a need to bring up some old data? When I say old data, it's like, maybe 10, 20 years ago.
No, pretty much everything we have to delete everything by after 7 years. Most of the time by 4 years.
Interesting. So backward compatibility is actually not something
As
that's
far as data
useful.
goes, yeah. As
Interesting.
far as programs, I don't know.
Okay. All right. That's kind of interesting. Um, I guess with EDD it may be slightly different. I don't know. I mean, state agencies are so diverse. It's different, between agencies. But assuming an agency needs, that backward compatibility, then dataset is the way to go because it doesn't need a program to process the data. Whereas, when you have a relational database, you can find the backup. The question is, once you quote unquote restore the backup, can the new database engine, is it backward compatible to process it to be able to represent that data? And then there's also the consideration of efficiency. So I'm gonna let it to you guys to guess which one is more efficient. And by the way, this is a trick question, so so keep that in mind. I'll just be sipping my coffee. All right. So which one do you think is more efficient when it comes to input output operations? Like, if I need to read a whole bunch of records, is it faster to read it from a database or is it faster to read it from a data set?
I would think database.
Okay. Anyone else? Ah, okay. So you're partially correct because the correct answer is it depends.
Oh,
It depends. Okay, it depends on a few factors. Okay, so let's talk about dataset first. When is it more efficient to read from a dataset? When you need to read something sequentially, when you need to read something where the dataset index is designed to do, a dataset is actually very efficient. One thing IBM does, that Unix and Linux typically do not even come close of doing, is IBM would actually use a high level concept, which is like a data set, and it and IBM would basically penetrate all the different layers of an operating system so that by the time it is stored on a DAS-D, the way a data set is stored on the DAS-D would make the access to the data set super efficient. The same thing cannot be said about Linux and Unix. So when you look at Linux and Unix, their file systems are basically set up to be an abstraction by design. In other words, they're basically saying once you get past quote unquote the file system, everything is just sequential. You're just reading a sequential stream of bytes. Now you can seek to random records within a stream and so on and so forth, but they certainly do not make it so that they try to optimize the efficiency um, of accessing content of a file. But IBM does it exactly the opposite way, because they make it very efficient to access records on the dataset, as long as you're accessing the dataset in a way that the dataset is good for. Okay, so if you have a sequential dataset where you just have records, sequentially arranged, and your actual access is natively sequential, it is super fast. Okay, because the disk head, of a hard drive can stay on the same cylinder, and then it just has to rotate multiple times and then to read the tracks of different cylinders, and that does not require a lot of seek operation because you just have one single seek. You read the entire cylinder, and then you move the disk head to the next track, and then you read the entire cylinder of that next track, and so on. Um, that makes it very efficient. But it also means the organization on the DASD is very specific to IBM, okay? Because it doesn't have the quote unquote general um, way of organizing files in a modern file system. NTFS is a modern file system, where you can create folders, folders within folders, folders within folders within folders. So there's a lot of flexibility when it comes to NTFS, when it comes to extension 4, extension 5 of Linux, and even IBM's own ZFS, okay, is a modern file system. But ZOS itself cannot directly benefit from those particular file systems. So now the question is, so if dataset is efficient, okay, in this type of access, then when do we use a database? So a database is not designed normally to be read sequentially. A relational database is very, very good at what we call a table join operation. So that's the relational part. Okay, I can give you a very quick example of what a relational database can do. So let's just say that we are dealing with okay. So on one hand, we need to store employees, okay, people. So in the organization of people, okay, we'll track employee ID, we'll track first name, we'll track last name, we'll track phone number, we'll track the address, and so on, okay. And then we'll have another system to track, let's just say, when a person comes into work, and basically time cards, okay. So if you need to keep track of time cards in a relational database, then you have multiple tables. So one table is only here to track people, and then the other table is here to track the actual time in and time out records. So now the question is, what does one record look like for time in and time out? Well, instead of having to repeat the first name, last name, and everything else, on a time card, the time card would actually only refer to the ID of an employee. Now, that particular ID can be the actual employee ID that we know of, but it can also be an internal ID that is entirely just internal to the system. So when you need to look up and go like, okay, I need to find out, how many days tech had worked this month and how many hours as a total duration, one table is not enough anymore, because if you just look up the time card table, if you look up all the numbers as IDs, and you will have no idea which one correspond to me. But if you look up the employee ID, employee table, then you look up and go like, okay, here's tag, this is his number, this is his employee ID, this is, and you can find information about me, but you won't be able to find when I check in and when I check out in terms of the time card. So to answer that question of how often or how many hours tech had worked in the past week, now you have to rely on a join operation so that the two tables will be joined by the employee ID. So you're basically going like, okay, we need to join the employee ID and the time card ID, time card table. Sorry, I misspoke. You have to join the employee table and the time card table where the ID is the link. Okay, so the key idea is you have certain fields within the record that serves as a link mechanism between the tables. So that makes it very flexible because now each table can be very simplistic, but by making use of queries, SQL queries, you can now have a very powerful way of retrieving data in a very in many different ways. So to do the same thing, if you try to access that kind of data, and the data is stored in in sequential data sets, um, that would be a lot more inefficient because now you have to resort the data first, so that you can run one tape and then run the other tape, adjacently, and then you can match up, the IDs in the same increasing order, and that's how you can join, quote unquote, have a joint operation when you really don't have a relational database. So for that type of thing, a data set is not very efficient. But a relational database, on the other hand, is super efficient when you just go like, I have never run this query before, but I think this data is going to be very helpful, in a business meeting. Those are called ad hoc queries. They're not built into the system. You just kind of come up with a query to produce or provide some kind of data just because, okay, this is the data that I need today. Relational database, very, very efficient with that sort of thing. With data sets, you're going to have to write several programs, to do it, and it's not going to be very efficient. So efficiency is a very tricky topic, because it depends on how you're accessing the data. Okay, if you access the data the way the data set is designed to do, then it's really good. Okay, data set has the efficiency. On the other hand, if you want the flexibility and you want queries, then database is the way to go.
Don't
And
you have to have a
mhm,
key? One
yes,
of the fields has to be a key in a database in
hmm
order to relate it to the other tables?
yes. So yes, you are correct. So in the table, so in the example that I was using, in the employee table, the employee ID is going to be called the primary key of the employee table because each employee ID uniquely identifies a record within the employee table. For each for each time card, okay, for each time card, there's also the employee ID, but in that context, it is called a foreign key because it is a way for a time card to refer back or to link back to a person in the employee table. So you are correct that you have to correctly identify the keys first. But relational databases allow you to identify different keys. You can only have one primary key, but if you want indexes to speed up operations, it does give you the flexibility of using any field for indexing operations. You can even combine fields to become, to make new indexes. Okay, I can give you an example. Um, let's just say that for some strange reason, okay, people look up things, based on gender and also year of birth a lot, okay, using those as a combination. So in a relational database, you can actually say, you can, uh, when you configure a table, you can basically create a special index, which is a combination of the year of birth and the gender. So any future search based on those two is going to be really fast. So that is also something that a database is very good at. Because after the table is created, you can still modify the properties of a table to include additional indexes. So that was a very good question. Thank you. But does it help to illustrate the differences between the two in terms of efficiency?
Yes.
Okay, very good.
Wouldn't a data set have to go through each line sequentially to locate information if you're just wanting a specific record
Yeah, it
versus
would be very messy too. So, okay, just think about it. I know I don't have the pictures to support this, but just think about um, the employee table as a employee data set this time. So the employee data set as a sequential data set. Now there are different types of data set that can be keyed as well, but if you think about a sequential data set, so the sequential data set now has to be sorted by some way, right? So are you going to sort it by employee ID? Are you going to sort it by, first name versus last name? Are you going to sort it by other attributes of the data set? So that's the first question. And then you have a different data set that will be storing the time cards, right? So the time card data set is also going to be sequential, where each record would contain the employee ID, it would contain the start time, and potentially the end time. Now that is only if you can correlate those two. So it is more likely than not that each time card is going to have, three different pieces of information: employee ID to identify whom, time, which is just basically a time, and a third field to indicate is it a check-in or is it a check-out. So if your time card is arranged this way, it is actually very difficult to find out when did tech check in and what is the corresponding check out time, in that particular table. So when you want to say, I want to generate a weekly report, okay, of which employee worked how long this week, so that we can print the paycheck accordingly, it's going to be complicated, because you have to make sure that both data sets are sorted by employee ID first, okay, if they're not originally sorted by employee ID. And then with a time card, you also have to sort it in a chronological order. So, so there are multiple things that you have to do to arrange data so that they quote unquote line up, so that this way you can basically scan through the employee data set. So you move on to the next one. You say, okay, now we're working with this particular employee ID, and then you have to go through the entire, or at least scan the time card data set until you find the first record of that particular employee, and then you can process, okay, start and start and start and, oh wait, hold on, this new record belongs to somebody else. So now you have to move the employee data set point and scan, go like, okay, now we need to move forward until we find that particular employee. So you can see the logic is not going to be, it's not going to be that simple. But in SQL, okay, that particular query is very simple. You just say select blah blah blah, whatever field you want from the two tables, and then you specify join by something, and then you just have to say, the employee ID of this table has to match the employee ID of the other table. It's called an inner join if you want to get into SQL terms, but that query is like just like that. Okay, at the snap of a finger, you're done. Does that kind of help to explain these two different types of ways of organizing data? Maybe a little bit.
Yes.
Okay, very good. How many of you know that your section is using a database like DB2 in addition of using data sets?
Me,
And you
Carrie,
work for
I work in database
which agency do you work for?
technology.
CDT?
Mm-hmm.
Okay. But CDT is kind of Amazon, right? So you support your clients.
Yeah.
Okay. Okay, gotcha. All
So
right,
I
so
work in the database unit,
okay.
and we have the database
Mm-hmm.
and the products that the customers use in order to run
Yep.
their, yeah. So it's kind of like DB2, but it's older than DB2.
What is the name of
Um,
it?
database.
Database.
Mm-hmm.
So it's like database but without the D,
Yeah.
like that?
Database.
ADAS,
Yep.
no E.
Huh?
No E.
No
No
E.
E. Yeah.
Database. A contraction of adaptable database system. It's and it's not an IBM product either. It was
Is
developed.
software AG.
Yeah, so it's Software AG, which is also a gigantic company too. And it is when it was launched in 71, it was a non-relational database, and then by 2019, just look at the time span in between. Um, it doesn't say that it turned into relational. So I'm looking through this stuff here. There are many different databases that are not relational, and database is not the only one that is non-relational. And 4GL, by the way, stands for fourth generation support, um, which is kind of their way of saying, okay, their quote unquote programming language is easier for people to learn. All right. I'm just reading the second paragraph or second section here. IBM said applications that are written in a pre-relational database such as Database are no longer mainstream and do not follow accepted IT industry standards. And that was 2015. However, an database can be designed in accordance with the relational model, while there are tools and services to facilitate converting database to various relational database. Such migration are usually costly. Okay, interesting. So, in your experience, are agencies converting from database to DB2 or Oracle?
They're converting to something else, and they're going elsewhere. And so a lot of the agencies that we have, as a matter of fact, I'm doing a decommission on a database because the client no longer is using it because they've gone and done something else differently. So
Hmm. Do you know where they're migrating to?
I I they went to DB2.
Oh, okay, they went to DB2. Okay, so that's logical because DB2 is an IBM product, for one, and it is also a relational database. Um,
Mm-hmm.
the nice thing about relational databases, okay, such as DB2, MySQL, Oracle, PostgreSQL, that's an open source database that runs in Linux, and a few others, is they all use the same language. Now there are dialects, okay? So SQL is a common language, but then there are also dialects. There are certain queries that will run in one database that won't run in another database. There are such things. However, for the most part, okay, most SQL statements can basically run on just about any database engine, and that makes it easier for people to cross over and go like, okay, I used to develop database applications in Oracle, but your shop is using DB2. It's not that big of a change. So that's also an advantage of using a relational database using SQL because it is a very standardized language. So it's also interesting, to compare those two. All right.
So I might want to look into learning SQL then, right?
I think that would not hurt for sure. Okay, seriously, I really think that that's actually a good idea. If you're seeing a trend of people migrating to DB2,
Mm-hmm.
learning SQL is I think is a great move. Now, since we're on this topic, if you want to learn DB2, but you can probably, okay, there are two aspects to it. One is, how do you connect to the database? And the other one is, just to get familiarized with the concepts related to a relational database and the syntax of SQL. In that case, you can use MySQL or MariaDB. I'll just give you a link here, just because we are on this topic already. So MySQL or MariaDB, they're basically the same thing. One is licensed under Oracle, and the other one is not under Oracle, but they're basically the same product. Both of these are open sourced, which means you can download it, and you can download, install on the PC, and it doesn't take up much resources to run either. As long as you just have a kind of toy database, and you're just experimenting and learning how to use it, it doesn't use up a whole lot of resources. But you can also find a lot of tutorials when that are specific to MariaDB or MySQL. And I think these two are great for learning purposes. There is no way, okay, let me warn you, there is no way any state agency or any financial institution is going to use any one of these two because these are not considered industry strength type of database. But
Mm-hmm.
the SQL language is the same. So I strongly recommend that if you have time, okay, this is not a bad thing to use your time on.
Okay, thanks.
Yep, you're absolutely welcome. Alrighty, so I'm gonna
AR
close.
offers a class in database using MySQL.
Say the one more time.
I said AR offers a class in
Yes.
databases using MySQL.
Yep. It's a CISP. Is it 350?
Don't remember.
350 is an Oracle class, but they still use SQL. So Lupe, the class that you're referring to, is it specific to MySQL, or do you think it is also with Oracle?
It's a database class, but all the program or all the we had to write all our code in MySQL.
Was Iraj teaching that class?
It was several years ago when I took the class, so
Okay, let me see if this looks familiar to you, because the other students may use this as a resource as well. Does that ring a bell?
I can look. I'll look on my transcripts and see what it is.
Oh, okay. All right.
I just
Thanks.
remember it was very, very. I wasn't prepared for that class. It was very
Well,
hard. Yeah.
even programmers are not. uh, Relational database requires a different way of thinking, and a lot of programmers, a lot of developers, when they take this class, when they take a database programming class, they cannot think in the query way, because queries are spatial and programming is sequential and linear. And a lot of programmers will try to use very inefficient ways to do the same thing that can be done like that in SQL. So it's a very specialized type of programming. But once you learn it, it is very, very useful as well. I would just put it this way: it will give you a lot of migration ability at work. All right. So I have lost track of my tab already. So I'm gonna turn this on. Let's see. We are. Where am I?
I believe it was
Yep, got it.
CISA 320.
Yep. And the system decided that I should sign in again.
Loopy, did you say CISP 320?
CISA 320
That was a long
3
time ago.
was no. I'm sorry. CISP 352 352.
352. And from AR?
Yep. No, sorry. It was Folsom.
Ah, okay. That makes sense now. That makes sense now. Because I know at AR we only teach Oracle, and 352 is MySQL, so it's from Folsom. Okay, cool. Yeah, where you guys have inter-agency differences, we have inter-campus differences.
351 as well.
Okay.
Thank you.
All right, so back to data management. All right, so next topic is about data sharing. Okay, so how do you share a data set? So this week actually talked about already. Okay, when we talked about, let me see, right, serialization. Okay, so when we talked about serialization, we also talked about data sharing. So within a sysplex, it is entirely possible to have a data set to be seen by different systems at the same time. But that doesn't mean they can all access the data set at the same time. Now, if they're all reading, I would suspect that it's okay. Okay, if every single job says in a DD statement and say I need this particular data set, but I only need to read it, that probably is permissible. On the other hand, if multiple programs want to make changes to the same data set, then it is probably not permissible. So only one job can have write access or update access to a dataset at any particular point. So this seems to make sense, right? Because you don't want to have multiple programs trying to make changes to the same dataset at the same time. But at the same time, it doesn't make sense. Let me give you an example. So let's just say that you are in charge of a program that will keep track of time cards again. Okay, so we have time card machines, at the entrances of multiple government buildings. And when people walk in, there's a way to indicate whether a person is walking in or walking out. That's actually pretty easy to do. And when a person walk in, we want to add a time in card to the dataset. And when people walk out, we want to add a time out card or check out card into the time card dataset. Does that make sense?
Yeah.
Okay. But we want everything to be centralized. We want to have one single dataset to keep track of all of the employees, of all of the agencies, of all the buildings that we want to track. But now we have a problem because when one building, is when the system of one building is trying to update, that particular data set, all of the other buildings cannot do anything. In fact, all of the other entrances, even of the same building, cannot do anything. They have to wait because we can only afford to have one job to access that data set at any time. And we are assuming that each entrance has its own quote unquote job or its own interactive program that will basically be able to put an entry into the time card data set. So now we have a bottleneck, right? Because this particular data set can be really, really long. If you think about the number of state employees and the number of times people go in and out of buildings, especially around lunchtime, right? That's really that's going to be a lot of transactions, and if every single transaction needs to be completely exclusive of all of the other transactions, then we have a problem. So in that particular situation, even though a data set can be shared with very high efficiency across an entire sysplex, it's still not going to work very efficiently. At the same time, a database, okay, because of the way it is designed, all you need in this case is an insert statement, with SQL. And the database engine itself, because I hope you guys still remember, what a socket is. A database subsystem is basically offering its service through what we call a socket. So every single time a client program, which is basically a job or an interactive entry system, so every single time the client says, hey, I have one entry to add to this particular table, it basically submits, it tries to connect to the database, and then once it connects, it will submit a statement, an SQL statement that says, insert into, and then whatever table name, and then the data, of that particular entry. And then the database engine is the one that needs to make sure that whatever updates it's making is going to be self-consistent. So that way, we are not going to be locking up one gigantic, data set just to add one more entry to it, okay? Because the database, a relational database, has a very efficient way of, handling these requests. So from that perspective, at a very fine granularity, a database is a much better choice for data sharing as opposed to a data set. Now, if the granularity that you need is not fine, okay, it's not just, oh, I just need to update or add one single record within a gigantic data set. If you really just need the entire data set, especially in a read situation, then a data set within an IBM Sysplex environment is going to be a better choice because it is one, it is very high in terms of efficiency, and then two, it just moves data a lot faster compared to queries to a database. So once again, which one is a better choice depends on a lot of factors. In the case of data sharing, it depends on, are you only reading or are you also updating? And also the second question is, what is the granularity of sharing? Are we talking about record level sharing or are we talking about data set level sharing? So those questions will help determine whether a database or a data set is a better choice. The next one is flexibility of queries. Okay, in other words, what answers, what questions are you trying to ask from accessing the data set? A query can also be an update type of query. Okay, so you can be updating something, But for the most part, when we talk about queries, most are read queries. We are not updating something. We just want to go through the database or the data set in order to get some information, to extract information from the data that's already stored. So in terms of the flexibility, I think this is just personal experience. There's no question a database offers a lot more flexibility. Now, with a data set, it is not like a data set can or a bunch of data sets cannot do what a database can do. It's just not very flexible. You probably have to end up writing multiple COBOL programs and sort the data set in multiple ways, generate a whole bunch of intermediate data sets in order to answer a question that can be formulated with a single SQL statement. Now, that may be nested and long and complicated, but nonetheless a single SQL statement when it comes to a relational database. So in terms of flexibility, except for very few situations, I think a database is going to win. A relational database is going to win. Any questions up to this point? No questions? All right, so we'll move on to conversion. You can convert between the two. But when you convert between the two, especially from a data set, usually the direction is from a data set into a table of a database. So in that situation, you probably have to identify what would be a primary key of that table. When records are stored sequentially, there's no need for a key, okay, because you're just sequentially going from one record to the next, to the next, to the next. But when you're storing data into a table of a database, then every single row, every single record needs to have its own ID. Needs to have its ID so that you can use the relational feature of a relational database. The conversion process, I cannot imagine being very difficult from a data set into a database. The other way around can be complicated because there are different types of data sets in IBM, and choosing the right one and having the right key identified is going to be can be challenging. Any questions, comments, feedback at this point? So I do apologize. I don't have any pre-typed notes, and I'm just kind of going off of the outline. But when I typed the outline, these are the content that was in my head. So I just didn't have time to write it all out. All right, no questions. All right, so we are now on to DB2. I'm just looking at the time. Okay, so we're now on to DB2. DB2 is IBM's own relational database. Um, I was actually surprised when you guys talked about what products are being used or what vendors are being used on IBM mainframe computers. I thought, okay, when I first got this class, I thought that most ZOS installations would be using fairly exclusive IBM products. But from what you guys told me, that really is not the case. There are a lot of third-party tools that different agencies have started to use, you know, uh, from many years ago. Is that a correct assessment?
Yes.
Yes.
All right.
We're starting to move more towards IBM products ourselves.
Okay, so the franchise tax board is trying to move into more just IBM products. How about the other agencies? Any indications from your mentors or managers?
We're gonna use IBM for a while, but we have a new project where there's a new unit. It's called modernization program where they're trying to update the uh, antiquated system of DMB, but they haven't said anything. What they're gonna transition into. I mean, I'm not in that unit, but there's
Okay.
just one big unit. All they're doing right now is the modernization process
Mm-hmm.
of
Okay.
the system. But so right now we're still using the old system, or we're still using IBM, and we also have like DB2s, Oracle, and stuff like that, different databases. Because I work in the division where they're grouped according to the system that they use,
Hmm.
like DB2 administrators. So I know we have those. We use those, and then we have Oracle system programmers. That's the
Hmm.
name of the unit itself. So I know we're using those.
Okay.
And then when we advertise positions, you would say required SQL experience and stuff like that. So anyway,
Well, the more reason to, if you have time to spare, the more reason to learn about relational databases. Because DB2 is one, Oracle is also a relational database. They both they can both understand SQL. So that means that's a good thing to learn because I think people are migrating more into relational databases these days. And of course, once you learn how to do relational database, they will tell you, oh, by the way, we are now moving from relational database to big data, which is also different. But I'm not going to get into big data. I think relational database is going to be okay for most state agencies for a long time. Um, there are also differences between different types of relational databases. We talked about this a little bit earlier. How MySQL, MariaDB, those are really good as learning tools, but they will never ever be used in an industrial setting because they were not built to do that. Now it doesn't mean that these things are not secure. It doesn't mean they are not stable. It simply means they cannot scale up. That is the main issue: is can they scale up or not? DB2 and Oracle are both very expensive products, and they can scale up by using clustering technology, which means the database, the how should I put it? The surface is spread across multiple mainframe computers, and as a result, it can scale up to a certain extent. By adding more mainframes, you can make the surface go faster, and it can only go up to a certain point, which is kind of the limitation of a relational database because it has to perform the join operation, and there's really not a whole lot you can do to make that part scalable. So that's kind of the deal. All right, so DB2 is an IBM product. It is a relational database. You can make queries out of SQL. And once you can make queries out of SQL, there are tons of front ends to generate reports, to have forms, to enter data, to analyze data, to QC data, and so on and so forth. And that's also the reason why SQL is so important, because once you understand SQL and your job is to kind of extract certain data out of a relational database, you can use a variety of front end products. Many of those can run in Windows. You don't have to actually touch an IBM mainframe interface whatsoever to make use of DB2 that is installed on the mainframe. Second point, it allows for very complex queries. Now, I have only personally written, queries, that are so complex, but I can imagine that there are queries that are more complex than that. Um, is anyone interested in what a SQL? You can just do your own search. Okay, I'm not gonna use up class time. But if you want to look up, nested SQL statements, you can just do a Google search. Um, but the bottom line is, they can be very complex and they can do a lot of things. DB2 is also a socket-based connected subsystem, which means the service can be offered to across multiple mainframes, across multiple sysplexes, and beyond. Technically speaking, because it is a socket-based connection, you can basically connect to a DB2 installation using the internet from anywhere within the access of the internet. So that can be across the globe if people open up the DB2 port. So that gives agencies a lot of flexibility, once data is stored in a DB2 database, because now they don't need to write COBOL programs anymore. The data stored in DB2 database can now be processed using just about any programming language today. You can use Python, you can use JavaScript, you can use Java, just to name a few. And uh, there's no restriction to use COBOL anymore. COBOL, on the other hand, is pretty much the only choice you have when you are using datasets. There are very few, if any, programming language that can directly handle the concept of a dataset. On the other hand, when we are talking about a relational database, hey, the only difference is how you make a connection to the database. But once you make a connection, the queries, how you process the result of the query will be identical, whether it's DB2, Oracle, MySQL, MariaDB, PostgreSQL, just to name a few. It's going to be the same way, which means you only have to learn things once, right? And you can now handle different types of SQL products. So that's kind of interesting from the perspective of an employee, because learning SQL and learning DB2 gives you mobility. It does give you a lot of mobility because now you can work with other databases as well. So that's the point that I have just made over here, okay? Because now it is language independent and also platform independent, especially from the client perspective. In this case, when I say a client, it is just basically the program that is trying to make a connection to DB2 in order to extract information stored in the database. That is usually called a client program. It can support safe, reliable, high granularity data sharing, which is what we just talked about with a time card example. So any questions, any comments, any feedback at this point? Okay, just one more thing, okay, because I do want to kind of look at this term just a little bit. A transaction is an interesting concept. So let's just say that you are writing an app, okay, writing a database app to keep track of inventory level for Amazon, okay? And you can probably imagine that Amazon being a international, corporation, it takes order from people all over the world, and a lot of times people may be placing orders, like at the same time. So let's just say that someone placed an order, and halfway through the processing of that order, there's a hard crash of the system. So now the question is, well, did that order go through or not, right? A transaction-based system or a transaction-based SQL server in this case can group multiple queries into one single logical unit. It basically says, until we get to the end, the last step of this whole bunch of steps, the end of the transaction, everything in the middle, they are all undoable. So in case of a hard crash, when the system starts up the next time, it would look at the log and figure out that, hey, the last time when we crashed, we were in the middle of processing this transaction, which invalidates the entire transaction. Then it has a way to roll back all the changes that happened into midway through the transaction. All of those changes can be rolled back so that the database can return to a point where it is self-consistent, which is very important when it comes to the level of stock and also other things where you want several items or several tables within the database to be self-consistent. So DB2, Oracle, all of the industrial relational databases, they all support the concept of a transaction. So I just want to mention this because this is also something that is very specific to databases. And the next main section talks about mostly datasets. So we'll get to this document, probably after a short break. But before the short break, I'm going to bring up the main points, and then we'll take a break of 5 minutes. And then when we come back, we'll go to the IBM document here.
I have
So
a quick question
yeah,
before you
absolutely.
start on data sets. So when people refer to IMS, is that the same as IDMS?
IMS, I just looked it up out, right after I learned that I'm gonna continue to teach this class. I looked up a lot of things right away. I did look up IMS, and IMS is a different type of database. And oh, okay, it's on a different browser, different
But
window. Okay,
did they change their name to IDMS?
let me look it up.
Or
IDMS. And I want to add IBM to. I have never heard of IDMS, but I have heard of IMS. And I'm getting a IBM document here. I'm gonna read it real fast. Okay, so I can show you what the document is. All right, so IDMS. Oh, this is just the support. There is no references that I can find that says those two are the same. How about we take a break now for 5 minutes, and then when we come back, hopefully I will have found the answer to this question. Would that be good?
okay, yeah,
Okay,
thank you.
sure. So we'll be back at 6:35. All right. So it's 6:35. I hope everybody is back by now. So I did a 5 tab, search, while we were taking the break, while you guys are taking the break. Um, to me, this is actually fun stuff. Okay, just looking up terms, understanding, and be able to uh, know what they're referring to. So these are all kind of interesting stuff to me. All right, so I can answer for sure that IDMS and IMS are different products. So,
Okay.
um, and let me expand on that a little bit if you guys don't mind. So this is the page that I first found about IDMS, and it is a product of CA Technology. So it is definitely not an IBM product. It uses what they call a network model, as opposed to the hierarchical model that IMS uses. So let me go find the IMS link. I actually looked it up somewhere here. I think I put it over here already. Yep, this is IMS. So this is IBM's own documentation. It's actually a book that you can download for free. So for those of you who are interested, it's not required reading. So don't worry if you didn't have time to print this out, because it's definitely not required for this class. But it is free, okay? And this is one of the for dummies series of books. And I would not worry about that title at all. Even though it says for dummies, it's not. Trust me, dummies won't read these books. Um, and I am going to post it in the channel chat. So this way it's permanent. Okay, so in the channel chat, I just posted the link of the IBM IMS for dummies. So IMS is they uses what they call a hierarchical model, where one item, okay, you can think of it as a tree, where one thing can have, okay, better yet, let me use the right terminology. Think of these as folders. Okay, one folder can contain subfolders, right? Each of the subfolders can contain multiple subfolders, and so on, right? But it is called a hierarchy because a file cannot belong to two different folders at the same time. Okay? Now, for those of you who have taken enough classes in Unix and Linux, will say, but Tech, that is not true. There is such a thing called a hard link. Okay, shut up. Don't say that, okay? Because those are very advanced topics, but as far as most people are concerned, a file system, the way we organize files using folders within a file system, is hierarchical, which basically means you can have containers, having subcontainers, having sub-subcontainers, and so on. But every object, including containers, can only belong to one level up containment. Okay, which is kind of a problem sometimes. Okay, if you think about photographs, okay, if you take a lot of photos with your cell phone and whatnot, if the only way to organize your photo is by date, by subject, by people, and so on, it's not very good, right? Because sometimes you want to search things using a different quote unquote index. So that's the limitation of a hierarchical type of database, which IMS is. So IMS is a hierarchical database. IDMS, on the other hand, is called a network model. It uses what they call a network model. And the difference is in the network model, it allows an object, one thing to be organized, to belong to two different, paths of containment. So now you can say, here's a picture. Okay, in the picture we have, let's say, it's a family get together in a park. Okay, so you might have one way to organize your pictures and go like, okay, these are all my family pictures. But you might also have an alternative way of organizing your pictures by the background. Okay, where did we take this picture? So now with hierarchical, not hierarchical, with a network model, you can have multiple containment, so that you can have, well, I mean, they have an example here of what a network model is, it basically just means that one thing, instead of just relating to another thing in a link, it can also relate to some other thing in somewhat of an arbitrary way. So IDMS in in theory is more flexible compared to IMS. IMS is now an IBM product, even though it did not start out that way, but it is now an IBM product. IDMS, on the other hand, is a CA Technologies product. So,
Okay.
all right, cool. See what 5 minutes can do. I actually found more stuff than that, but I think these are the most relevant portions of it. All right.
Okay.
Yeah, go ahead.
No, thank you.
Oh, you're welcome. So this book can be useful if you are, into if your agency is using IMS and you want to understand more about IMS. This is a good book to get into it. Okay, I read through a portion of this, and I think it's written in a fairly um, the way it's written is fairly easy to understand. So if not, just bookmark it. Okay, and just say that these are things that I might want to get back to when I have time. Okay, because it's free, it is a book, it's organized in a linear fashion, so it's good. It's a good resource. So I'm gonna close this. The link is already in the channel chat. And then this one talks about IDMS support. I think we can close this one. This one is from Wikipedia. I can copy and paste the link into the channel chat, just so that anyone who's interested, you can refer to that. And then I'm gonna close it. This one is about IMS. So this is a longer and more technical discussion of IMS. This is the interesting thing about IBM terms is when you read the term, it doesn't say anything about what it does. Information management system is like how, what are we talking about here? Doesn't have any indication whatsoever. Doesn't have anything that says oh, this is a way to organize data in a hierarchical way. Nope, none of that. So, but I'll put this link into the chat, the channel chat as well, just so that anyone who wants to read a little bit more about IMS can do that. All right. So the focus of this portion of the lecture was intended to be dataset. That's where we are supposed to be talking about. And let me go find that outline first. There we go. All right, so this is the link that I'm supposed to follow, but I didn't quite finish all of these points here. So we'll get to these points first, and then we'll get to that link. All right, so datasets. We talked about a lot of these topics already. How this is very backward compatible. Because that's how we started off. Many years ago, before the 1960s, a dataset exists basically as a stack of punch cards. It is very efficient in sequential and high volume data processing. Not so much when I just need that one record within this whole bunch of stuff here, and I'm going to search by something that may not even be indexed. I would say definitely not very friendly to modern programming languages. Languages like Python, like JavaScript, they are not natively supporting the concept of a data set. But COBOL programs, on the other hand, can access data sets very efficiently. That's basically how those two are basically co-evolved over the years, over the decades. Data sets are also not easily shared across operating systems and across TCP/IP connections, which limits once you have a data set, especially anything that is non-sequential. How do you read the data set? You pretty much can only use an IBM mainframe use ZOS, a Z system to read data sets. You don't really have a lot of options there. So that's basically the last point. Data sharing options are limited if you are using data sets. So when we refer to data sets, there are many different types of data sets, and that's what that link is going to bring us to, is an IBM document that talks about the different types of data set. There's a lot of content here. What we'll do is, the first thing is for me to, oh, that doesn't work too well. This is also in ZOS Basic Skills. I believe you have a printout of that book. Is that correct or not?
And does
Yeah, it appears to be.
Sorry?
It appears to be that's what our ZOS concepts book is.
Oh,
I
okay.
looked at the first page.
Yeah,
it
it's
seemed to
under
line up
ZOS
pretty good.
Concepts. Yep. Okay. Okay, that's good. Because now you can locate, these pages, in that book, so that you have a paper version of this to read from. So there's a lot of information here. When you look at the subsections, okay, this one explains what is a data set. And I'm just going to read these, paragraph by paragraph, which is going to be a little boring. In the simplest terms, a record is a fixed number of bytes containing data. That really doesn't tell you much, except it does. Fixed number of bytes is going to be the key here. So this means if you want to use a record to represent a contact, and when I talk about contact, I'm talking about the same kind of contact that you have on your cell phone, where you have a person's name, under that person's name you have different phone numbers, because most people, have a landline and followed by at least one mobile. And the contact usually would also track email addresses, websites, other IDs, in social media, and so on. In in a data set, it is a fixed number of bytes, which means every single contact, you have to pre-allocate, or you have to predetermine how many bytes you want to use per record. So that is kind of bad in a way, because what if I'm talking about someone who has just a cell phone number that I want to record? Then what about those extra fields, right? What about the field that ask about the landline number? What about the field that ask about the Discord ID? What about the Instagram ID? What about the Zoom ID, and so on and so forth? All of those would be empty. Okay, but they're still chewing up spaces. Okay, because every single record is going to be the same size. The problem also happens in the opposite direction. So years after today, and you decide that, hey, we have so many new social media. I want to extend a record to also include IDs of those particular social medias, so social media presences. You cannot do that easily, because you basically have to create a new data set, copy the records from the existing data set to the new data set, where each record is bigger, longer, because it contains more fields compared to the one that you have already constructed. So that really is one of the limitations of a data set, is you can't really extend it very easily. In the case of IBM mainframe, I believe there's also a limitation of a record can only have up to 78 characters. Is that true? Maybe.
I thought it was 80.
80.
Yeah, 80 is the total
No.
width.
I know it could be more than 80. You mean a record?
Mm-hmm.
I thought I saw somewhere in here. I can't find it now. Never mind.
Oh, it's 20.
I know I've had records that are
Longer.
133 characters.
Okay. Well, 132 is also a kind of not so arbitrary number. Do you guys know why there's strange limit of 80 and then another strange limit of 132.
One is fixed and one is variable.
No, they're both fixed. 80 is how many characters you can fit on a line when you use 12-point font on a letter size. And then 132, if I remember correctly, is on one of those printer those mainframe printer things where you can have a wide format. You can fit 132 characters on a line because of the width of the paper. So both 80 characters versus 132 characters in quote unquote one record, which is basically one line, is limited by the width of the paper. It's a physical limitation. So they're both descendants of these physical limits, which is kind of
Oh,
interesting. Go ahead.
on well, I'm looking at, I don't know where it would be on yours. I'm looking in my book on page 42, and I don't know if I'm reading this right, but it's under the dataset record formats,
Hmm.
and it mentions that under variable that a record can be under the variable anywhere from 4 to 32,760 bytes.
Okay, thank you. So it's no longer limited to how many columns you have on the punch card. Okay, I get it. Thank you. All right, so under the organization, there are different types of organization. Sequential is the easiest one, so I'm just going to read this paragraph and then we'll go back and talk about it. In a sequential dataset, records are data items that are stored consecutively. To retrieve the 10th item in a dataset, for example, the system must first pass the preceding 9 items. Data items that must all be used in sequence, like the alphabetical list of names in the classroom roster, are best stored in a sequential dataset. Well, okay, so let's talk about a sequential dataset. Now, a sequential dataset simply means that you have to sort by one of the fields within the record at any particular time. But it doesn't mean that you cannot resort it. Okay. Let me see if I can give you an example. Okay, time cards. Okay, remember the time card example that I was talking about. So when we append time card records into a dataset, it's in chronological order. Okay, it makes sense because every single time somebody walks in or walk out of a building, of an entrance, I should say, you are basically just appending a single record that will include the employee ID, the time, and also which entrance of which building, or possibly those two are combined into one single entrance ID. So you'll just be appending all of these things, and naturally they're all going to be chronologically ordered. But that order is not very conducive, if you just want to figure out, okay, I need, to have a summary of the time card for TAC, okay, for the past week. And we want to figure out, how much time he has, worked, based on those time cards. So in that case, maybe not, we want to process it in this particular order. You can always resort records within a sequential data set. So you can resort it using employee ID. You can resort it using entrance ID. So this way, we basically bunch up, okay, all of the records related to one single entrance to be in one contiguous bunch of records. That makes it easy, if you want to just tally up, okay, um, how many people got into and out of a building, one particular entrance. So you can always resort, and somebody's going to say, somebody's going to ask, but isn't that very inefficient? Now that okay, for these operations we want to sort a sequential data set in this particular way, and then for the other job we want to resort it using a different field as the sorting criteria. Well, the answer is actually quite interesting because there's a sorting algorithm called merge sort. It's very very efficient when you're dealing with sequential data. Even with the reels of tape, it is still very efficient with this particular sorting algorithm. And if you look into the current IBM mainframe computers, they actually have specialized hardware for sorting. In other words, sorting is something that is central to the processing of data sets in a lot of IBM jobs. Otherwise, they would not, have hardware assisted sorting. So I just want to bring this up because it seems to many people, especially modern day programmers, that these would be very inefficient operations that you have to resort things, one way of sorting for these jobs and one way of sorting for those jobs and so on. That is actually taken into consideration, with these IBM mainframes, which also makes the IBM mainframe computers unique in many many ways because they have hardware assistance when it comes to specialized processing, such as sorting a huge gigantic data set. It's like bam, they're very efficient with doing this sort of thing. The next one
Okay,
is
so that's
yeah,
a little confusing for me
yeah, go ahead.
as far as okay. So maybe I'm jumping ahead, and you can just tell me to stop. But so a sequential data set, all the records are in sequential order,
Hmm.
um, and then a partition data set has members in it, but the members themselves are sequential.
Well, let's go ahead and read the next paragraph, and then we'll compare these two. A partition dataset or PDS consists of directories and members. The directories hold the address of each member and thus make it possible, for programs or the operating system to access each member directly. Each member, however, consists of sequentially stored records. Partitioned datasets are often called libraries. Programs are stored as members of partitioned datasets. Generally, the operating system loads the members of a PDS into storage sequentially, but it can access members directly when selecting a program for execution. Okay, so what this is, the way I'm reading this is a single partitioned dataset has multiple basically members inside it. So the directory is basically just a structure to help the system locate where each member is located within the dataset itself. So at the top level, we have a dataset, and then within the dataset, we have first, a directory structure of some kind where it probably has a mapping between the name of the member to the position within the partitioned dataset. Each member, on the other hand, occupies a contiguous area, within the containing partitioned data set. And within that portion, each member is sequential and it can have multiple fixed size records. That's the way I'm reading this. Does that kind of make
No,
sense or not?
that makes sense to me.
Okay.
Um,
How about the rest of the class? Is that okay, or do you want me to? I can illustrate it, by the way. I don't have my tablet set up, but I can illustrate this using a spreadsheet of all things. Do you guys want to see it as an
So in other
illustration?
words,
Hmm?
the directory can have numerous members, and each member can hold certain criteria data that you can access when necessary versus having a huge, large sequential data set that has everything where it has to read everything. Is that basically?
Um, from what I'm understanding, I think you're correct, but I can also give you a kind of more pictorial representation. Okay, so let's just say that uh, I'm using the row number as location in the file, okay, or roughly, that is. So we'll have three members here. Okay, so we'll have member one, member two, and member three. So the first um, bunch of bytes within a partitioned data set would be the directory. So the directory will have the name of each member within the partition, or each partition within the data set, and an offset to where I can find it. So if I want to use row 4 to start member 1, then we'll have member 1, record 2, record 3, and so on. So this portion is sequential, and all of these they belong to member one. So in the directory, member one will have at least a indication of where I can find um, the actual records corresponding to member one of this PDS. So member two, can start with what in this spreadsheet is location 7 or row 7. So now we have record 1 of member 2, and let's say that one only has 2 records. And now member 3 can start with row 9, and this one may have 4 records. So we have record 1, record 2, record 3, and record 4. So technically, these 3 rows, um, they are records of member 1, and then the next 2 are records of member 2, and then the last 4 are records of member 3. Is that kind of helping to illustrate what I understand as a PDS?
So in your time card example,
In the
if
time card, go ahead.
if we named each member an employee,
Hmm.
as the person timed in, we could write to that particular member, and each member would just have each employee's time in or time out.
Now, we certainly can. The problem is when you want to insert a new record, it's going to be very costly. So let's just say that member one needs a new record, okay? So what needs to happen here is we need to shift everything down by 1 to make space for record 4 of member 1. So it's not very easy to insert new records nor to delete existing records within this format. So it's not really useful for things that need a lot of updates. But for things, okay, so if we go back to the description here, it is focused on programs. Okay, so in this case, let me find where it is. Uh, there you go. There you go. So right here. So partitioned datasets are often called libraries. Programs are stored as members of partitioned datasets. It doesn't really quite refer to PDS being used to store data that much, but it is almost, from what I can read here, it's mostly used to store programs. And those are the things that are usually just read only and not, you don't modify those things very often. And it's really good for those because if you just need to read and find out, okay, tell me where is record 2 of member 2, we know where to start. Okay, so this is record 1, and then we just sequentially look up, oh, here's record 2. So that's the way I read this particular paragraph here. Is PDS is mostly used to group programs into libraries so that related programs are grouped together, so that instead of having one program being a individual data set, you have basically tons of tiny little data sets. We now say, oh, okay, wait, because each program is not really that big, we'll have each program being a member, and then we can group multiple programs as members within the same PDS. So that's the way I'm reading this paragraph. Is that okay or not?
So, Loopy, could you help me understand or like relate that to like our Rex class? So every member that we had in our partition data set was a program that we wrote for Rex. Is that right?
Yes. Every Rex program that we wrote was in a PDS.
And so it
and
was
our data that we used in the class was in a sequential file.
Okay.
So, but there is a way to put in the one reading that I did for that class. They talked about there is a way to store data in a
PDS.
PDS in a member.
okay.
Yeah, you
We just
can.
didn't do it that way in the
Yeah,
class.
because it's costly. You can. It doesn't mean that you cannot do it, but by inserting, because based on how this is described, um, the way it's usually done is they probably leave behind spaces between the members, so you have some leeway within between the members. You can probably add a few records before you have to shift everything down. But eventually, you still have to do it. Does that make sense? Let me give you another example of why storing data using a PDS is not handy. Okay, so let's just focus on the three records of member one. If I want to delete record two, what do we have to do? Remember, within a member it's supposed to be sequential, and within a sequential data set or within a sequential records, you cannot leave gaps behind, right? So in order to delete record two, you're gonna have to move record three up to and everything has to be shifted up within member one when you delete any record within that member, and that is usually considered fairly costly operation when you need to move a whole bunch of data when you delete one single record.
And I think that's the difference between a PDS and a PDSE. Where a
Okay.
PDSE does that.
Yep. Does what? Sorry.
It has its own indexing,
Yep.
and it does not have to be reorganized or recapture lost data. It automatically takes care of that for you.
Yep. Okay. That makes sense because um,
It's not one of the things in the book. It doesn't discuss it.
there. This is the limitation. This is why we have that limitation. Is within a member, the records are sequentially stored. That is the reason why a PDS has that costly operation. When I said, when we delete record 2, record 3 has to be moved up because it doesn't have a mechanism to say, oh, where do we find the next record? Oh, skip these, empty space here and get to the next record over there. It does not seem to suggest that it has that mechanism. All right, now we move on to VSAM, and I'm looking at the time. VSAM is actually even more complicated than that. There are three, if I remember correctly, there are three different types of VSAMs. Key sequenced dataset is one of the three, and I actually looked into that. So working with datasets require an understanding of the physical and logical structure of a dataset and how ZOS accesses information in the dataset. Now, without even getting into the details of this is also one major difference. One major difference between a dataset in ZOS versus a file in Unix and Linux and NTFS and basically anything that is not ZOS. Because a data set actually specifies how things are physically organized within a DASD or within a tape, as opposed to a file in Unix and Linux. Unless you have a specialized file system, most file systems in Unix and Linux do not have any association between how things are logically organized versus how they're physically organized on a disk. There is that abstraction which is intentional in those particular file systems because in those file systems they don't want um, the tie between the logical organization versus the physical organization. But there's a reason why IBM makes specifically and intentionally make makes this particular connection between the logical and the physical organization. This allows for very high efficiency, when it comes to accessing the data, because you can keep everything. This is back in the old days when we have hard drives. Because now people are migrating to SSDs. It's not as much of an issue. But when we have actual physical hard drives, one of the biggest price people have to pay, in terms of how much time to access something, is the seek time and also the rotational delay. So, are you guys familiar with those terms? What is the seek time and what is the rotational delay on a hard drive? I'll explain it. Um, hmm. Okay, so instead of having me to draw the picture, I'm going to search and see if I can find some pictures online so I can actually just point to those things. So rotational delay and seek time. Pretty sure there are images that we can use. There we go. This is a good one. I'm just gonna take a screenshot and then we'll move it to where you guys can see. There we go. All right. So this is a picture. So what you can do. So this is each surface. Like this is one. This is another surface. This is another surface. So each one is a platter, and I believe that term maybe. Yes. So they do specify the term of a platter. So a platter is a physical thing. Okay. If you take apart a hard drive, there are basically disks, okay, and there are three in this case, so that we have disk 1, disk 2, and disk 3, but they're called platters. On each platter we have two heads or two surfaces, one on the top and one at the bottom. In this case, they're only using the top as a surface that is storing data. So on each surface that can store data, there's a disk head that is connected to an armature. So this portion here is fixed, but the armature can move. So you can kind of see that how by moving the arm, you can position the read-write head onto different portions of the same platter. So now we refer to what is a track. So a track is basically a circle on a particular platter corresponding to the position of the disk head. That would be the track that is being read. When you look at the tracks of all the different platters at the same time, so because the disk head of the three platters are in the same position, because this arm moves all the disk heads at the same time, so when you look at this particular track, and this particular track together, it is called a cylinder. When we have a cylinder, we also have sectors. So this part here is one sector, this part here is one sector, this part here is also a sector. So a sector is referring to a particular portion on a particular track. So are those terms okay so far?
Yes.
Okay, very good.
Yes.
So now, we look at the time to move the disk head so that we can read from one cylinder to another cylinder. That amount of time is counted in milliseconds, in multiple milliseconds. 1 millisecond is 1,000th of a second, which to us is a very short amount of time. But in the computer world, a few milliseconds is a huge amount of time. And that is because a Z15 based mainframe can have 12 cores per drawer. Let me see. Yeah, so it has 12 cores per drawer, and you can have up to 5 drawers. Each core can run at 4 gigahertz. In other words, if you're talking about how much computation can be done in 4 milliseconds, a few milliseconds, it's a great deal. Okay, there's a lot of processing that can be done within the time it takes to move the disk head from one cylinder to the next. And there's also the rotational delay, because it is possible that the sector that you want to read, let's say it's this one, is not under the disk head right away. So now you have to wait until the disk to rotate so that the disk head that you are trying to read from is under the disk head. So that's the rotational delay. So now you have two types of delay, because you have the seek time, and then after the seek time, you end up with a rotational delay. Those two cannot happen at the same time because they are asynchronous. There may be ways to kind of minimize and have those two basically try to coordinate and reduce the total latency, but the latency is going to be in at least milliseconds. Okay, which is a long time when it comes to how much computation can be done. Why is that important? Depending on the file system, it is entirely possible that the data set, one portion can be here, one portion can be here, one portion can be over here, one portion can be over here. So when you try to access that file in a sequential way, if you want to access that particular data set in a sequential way, then you're talking about moving the disk head multiple times, and each time you have to wait for the rotational delay. That is very, very inefficient. So what IBM has decided to do from a long time ago is to have a link between the logical structure and the physical structure of how a data set is stored on the DAS-D. So how is that done? Well, they basically make simple rules of saying, okay, the same data set has to reside physically on the same cylinder, and the cylinder is organized in a concentric way because this is the center of rotation. So when you organize cylinders in a concentric way, you're basically reading everything within a cylinder first. Now you can read multiple tracks within a cylinder at the same time. So all three tracks here can all be read at the same time. And if you organize your data so everything is sequential, then you're just reading one sector and then reading another one, reading another one, reading another one. So you never really waste time waiting for a sector to rotate halfway across just to access one single sector. And then when you organize the cylinders in a concentric way, then you're also minimizing, the movement of the disk head, and therefore you still have to move the disk head, you still have the rotational delay, but when you are reading the data sequentially, you are minimizing how much physical delay is incurred in the operation of the DAS-D. And in this case, this only applies to a hard drive. It does not apply to an SSD. So is that okay so far? Does everybody kind of at least get a general idea of um, all the physical stuff that has to happen within a hard drive that can cause a lot of delay if we are not careful making the logical structure of a data set to correspond to the physical way of storing that data onto a DAS-D? Are we good so far?
Yes.
Yeah.
Okay, very good. Yeah, you might find me doing this a lot, because I like to explain why things are the way they are. So sometimes it might get a little bit out of context, but I think in this case it's actually relevant because this is one major difference between ZOS and most other operating systems.
I have a
That's
question.
Yeah, go ahead.
This is Jennifer.
Yeah.
Sorry. Um, you showed us that cylinder. So let's say we allocated a data set and we use PDSE.
Mm-hmm.
So the PDSE is indexed, right? So there's an index that's the locator where let's say you're gonna search a member, and instead of reading the whole thing like sequential order, if the index will determine where you could go directly into that cylinder or the block
Yes.
record name. Okay.
Yeah, so the
Okay.
index is usually specified also in cylinder and block. Um, there's a specific format, I cannot remember that now, but how a record is specified in the index uses the physical geometry of the hard drive. So that way it can directly translate to basically commands that can get through the I/O channel to the hard drive controller, and it's a direct thing. You just tell the hard drive controller and say move the head to over here, and you'll start reading at a particular sector. So it's very optimized to make use of the hardware.
Okay.
Yeah. Yeah, this is one major difference between, as I said, what a data set is and how it is actually very hardware dependent in terms of the structure. So this page is really just kind of talking about the major terms. We talked about all of this already. What is a data set, what is DAS-D. I think DAS-D also refers to SSDs, is that correct?
I'm not sure.
Not sure? Okay. Because a SSD or solid state drive definitely supports direct access. Go ahead. Oh, I
Oh
thought.
no, I just cleared my throat. Sorry.
Oh, okay. I thought somebody was mentioning or commenting on that. Cylinders, we explained a cylinder is basically just tracks of multiple platters. When collectively we look at multiple tracks at the same concentric circle of multiple platters, we look at that as one single cylinder, which is just kind of graphically, it looks like a cylinder. And then tracks is just one single concentric circle on a particular platter that a disk head can read. That is called a track. And then a record is stored within a track. So records have a logical record length, and it also has a different types of DAS-D impose different maximum lengths for records. So this kind of goes back to what Lupe mentioned earlier. It is a range, but that range is going to be dependent on the hardware, because it depends. Right here it says DAS-D, the type of DAS-D impose different maximum lengths for records. And that once again has to do with the efficiency of reading the records, because if we spill over a record, so a single record can be on two different cylinders, then it is not going to be very efficient reading that record, because we want to keep everything within the cylinder if possible. Records are either fixed length or variable length in a given data set. Traditional ZOS data set have one of 5 record formats: fixed, fixed blocked, variable, variable blocked, or undefined. And then we have the definition of a block. Records can be grouped into data blocks, which are units of recording on disk. Blocking makes processing more efficient because ZOS can access an entire block at once instead of reading or writing records individually. Block size is the physical block size written on disk for fixed or fixed block records. For variable and undefined records, block size is the maximum physical block size that can be used for the dataset. So what this entire paragraph is saying is the block, when logically, when we access a dataset, it's record by record. But when the operating system is interacting with the DAS-D, it is no longer record by record. It is going to be block by block. The reason is really simple, okay? Because a record can be fairly small, okay? If you think about, a typical record size of 80 columns, okay, which is 80 bytes, that's not really a lot, okay? But you still have to go through the same motion of setting up the I/O channel, okay? You have to, and then the I/O channel has to tell the DAS-D, what track, what cylinder, and which sector that particular record is residing. And then when you read the next one, guess what? It has to go through the same motion again, but it's in the same cylinder. We don't have to. We really should not have to mention that again. So what a block is it relates to the geometry of the DAS-D. It's the smallest unit that can be used when the operating system is reading or writing directly to or from the DASD. So a block has to do with all the physical stuff. So when the block, what a typical block size? Okay, I'm gonna let you guys guess what is a typical block size of a DASD. This has to do with virtual memory that we talked about a few classes ago.
4K.
Yep, exactly. There's a reason why a page, a frame, and a slot are 4K, has a length of 4 kilobytes, which is 4096 bytes. Okay, because that is the hardware configuration of the smallest unit or the smallest chunk, size that we can read from or write to a DASD is 4096 bytes. Typically, okay, it's not exclusive, but if you look at most of the modern devices, I would not be surprised if one block is 4096 bytes. So what does that translate to when you have record sizes of 80 bytes? Well, it means when you have one single block read, you'll be reading in, okay, what is 4096 divided by 80? That many
51.
records will be read in one single I/O operation. So now when your COBOL program is reading record by record, the operating system is just going like, okay, do we have to read another block in? Nope, we're still good because we read 4096 bytes, and every single time the program, the application, the job is saying, give me another record, you're just moving 80 bytes from the entire block that is read. You're just moving 80 bytes into an area where the job can read, as a record. So now you can do, okay, I'm just going to do this on the side. My mental math is going down the toilet today. So I'm just going to do it. 4096 divided by 80 makes about 51. Okay, so now you can read about 51 records from the perspective of a job using only one single actual I/O operation to the DASD. Instead of 51 individual access to the DASD, you have one single access to the DASD. So that vastly improves efficiency in the system. So that's why there's a block size and why the block size is important.
So they can read all 51 at one time?
Yes. The operating system is reading all 51 at once, but when the job is reading the records, the operating system is saying, okay, here's the next record, here's the next record, here's the next record. In other words, the job has no idea of when the operating system actually needs to go to read the next block in. That is entirely internal to the operating system.
Okay.
Yeah. Yeah, you can also kind of imagine that block size will probably increase in the future. Now, when that future is, I don't know, okay? But as storage devices are larger and larger in terms of capacity, and record sizes are also increasing at the same time, it only makes sense that the block size would also increase. Interestingly, the concept of a block size is not unique to IBM. So when you use certain utility programs in Linux and Unix, they can also let you specify a block size. And also very interestingly, one of those programs is called DD in Unix. Okay, you guys are not getting it, but yes, there is a program called DD in Unix, and it's a very
DD statement.
Huh? Yeah,
Like
DD is a
DD
statement. Yeah, DD is a statement in JCL, but it is actually the name of a command in Unix and Linux. I can show you this. I know I'm digressing a little bit, but sometimes it doesn't hurt because some of you eventually will have to learn Unix as well. All right, so here's DD as a command. And it's a very dangerous command to use as well because if used incorrectly, it can wipe a drive. But basically, in IBM's term, it can wipe an entire DASD using a very simple command. So, especially when you're running with root privileges. So, anyway, it's just interesting how sometimes, I'm pretty sure in this case it's a coincidence. And this command has existed since 1974. It's relatively young compared to IBM mainframes. Alrighty. So where were we? There we go. Alright, extents. Space for a disk dataset is assigned in primary and secondary extents. An extent is a contiguous number of disk drive tracks, cylinders, or blocks. Dataset can increase in extents as they grow. As with blocking, the use of extents is more efficient because reading or writing contiguous tracks is faster than reading or writing data that is scattered over the disk. So an extent is basically another unit. An extent is measured in units of blocks. Well, actually, I take it back. It's measured in disk drive tracks, cylinders, or blocks. So it can be one of these three as the unit. And when a data set is allocated and it needs to be bigger and bigger, it is only increased as in number of extents. So it is not going to be increased in number of blocks unless the measuring unit is in blocks. So an extent is a different unit for measuring how much space a data set is occupying on a DAS-D. The primary one is significant because everything that is on the primary extent is easy to get to, and then the secondary extents, are further, quote unquote, further away when it comes to physical accessing those secondary extents. I believe, when they talk about the more advanced types of data sets, that part will be mentioned. Volume is used to refer to a disk, so a volume ID is a unique ID to refer to a particular DAS-D connected to a system. The 6-character name of a disk or tape volume is called a volume serial, which in most other operating systems is going to be the I think it's called a UUID, of a device. UUID stands for, I know one of the U is universal. Not sure about the other one. Oh, it's universally unique identifier. Okay, UUID. The full name is universally unique identifier, and that is the standard used by most other operating systems to uniquely identify a drive within the system. But in IBM, it is called a volume serial, which is 6-character long only. UUID is much longer than that. Device type, what model, and then organization is how we are organizing the data within a data set. I'm looking at the time. Well, we are almost running out of time for today's lecture, so I am going to pause the lecture at this point. Are there any questions? No questions? All right. I'm just wondering how many of you have exposure to Unix already, because I think some of you are going to take classes, right, in Unix.
I'm going to take a class, but I haven't been exposed to it yet. So
Okay.
it was just recommended by my unit that I do. So.
Okay. And all right. So before I leave you guys to get your dinner and kind of finish up today, I also want to mention just one thing, because most people look at Unix as a kind of industrial operating system that is kind of strange, and most people don't use it. That is actually not true. If you have an iOS device, or if you have Mac OS, if you have a Mac, that is technically Unix at the very core. That's Unix. If you have a phone that is an Android device, it is going to be a Linux device, which is basically a form of a clone of Unix. Okay, I wouldn't say it's exactly a clone, but because it's not exactly the same, but it's very similar to Unix. So if you have a mobile device, chances are it is Unix based, okay, or Unix, very much Unix related. If you have a smart TV, okay, it is also likely to be Unix related. If yeah, it's interesting how many things are actually Unix related or Linux related today. So things that you learn about Unix or Linux actually has a lot of applications beyond your work environment. So I just want to give you that context, because when you learn something, you want to know, to what extent that stuff is going to be applicable. And I'm just going to tell you, Unix and Linux has a wide application once you learn that stuff. All right, so we are out of time today. I will see you guys on Wednesday for sure. And hopefully by that time I would have typed, the usual text note, at least up to a certain extent. It's going to be very hard pressed because my other classes are also going to have final exams, so I have to get those ready and get some of the past exams graded also. So I have a lot of stuff stacked up also. Um, so we'll see. Okay, we'll adapt, as
Okay.
7 of 9 says. We'll
Thank
adapt.
you.
Yep. Alrighty. See you guys
Okay,
on
thank
Wednesday.
you.
Hmm.
Okay,
Yep.
All
bye.
right. Bye.
Thank you. Bye.
Thank you.